So the question was help on how to graph uh, a system of equations in two variables. So we're going to go ahead and graph this first, and then we're going to interpret the graph to determine if we have one solution, no solution, and infinitely many solutions. So the first thing you want to do is when you're graphing a system of equations, well, what I like to do is I like to put each of these equations in slope-intercept form. So I'm going to work with the first equation, 2x minus y is equal to 4. I'm going to solve this for y. So the easiest thing to do to solve for y would be to add the y to both sides and then subtract the 4 after that. So this would give us 2x is equal to 4 plus y, and then subtract 4 from both sides, and we're left with y equals 2x minus 4. And we can go ahead and graph that. That's in slope-intercept form already. Remember, slope-intercept form is y is equal to mx plus b. So in this case, our y-intercept is negative 4, and our slope is 2. So we start at negative 4, then we go up 2 and to the right 1. And because this is a linear equation, we only need to have 2 points, and then we have our graph. So we start at negative 4, 1, 2, 3, 4, that's our first point. And then the y-intercept, the slope is 2, or 2 over 1, so we go up 2 and to the right 1. You only need 2 points, but you can do another point if you want to, so we can go up 2 and right 1. So that's our first line that we graph. And I'll do the second one in a different color. Let's do red. So now I'm going to do the 3x plus y is equal to 6. And to solve this, we can just subtract 3x on both sides. The reason we had to use more than one step on this first equation is because there was a negative in front of this y. But because our y is positive here, once we subtract the 3x over, then our y is already isolated. So we have y is equal to negative 3x plus 6. And I put the x term first because remember we're working towards just y is equal to mx plus b, slope-intercept form. So now I'm going to have to draw a few more lines on the graph here because our y-intercept is 6, so we need to go up 6 initially. All we have is 4, so 1, 2, 3, 4, 5, 6. So our first point is 6 on the y-axis, and then our slope says go down 3 and to the right 1 because it's negative 3 over 1. So 1, 2, 3, and then right 1. Then 1, 2, 3, and right 1. And you can see we have a point of intersection here. So, to determine if there's one solution, no solution, or infinitely many solutions, there's a few things you have to look at. So the first thing we want to look at is, do the graphs intersect? Yes, they do. They only cross at exactly one point right here. So this tells you this is only one solution. And the solution is that point of intersection. What point is that? We're on the x-axis and we go over 2. So the actual solution would be 0 and 2 and 0, I'm sorry. 2, comma 0, because we went to the right one and we didn't go up any. So now, say you got a problem where there was no intersection. Something like this. You graphed, you did the same thing, you put it in slope-intercept form and you graphed, and you end up with two lines that never cross. Well, because they never cross, they don't have any points in common, so then you would have no solution. So your solutions are just the points that the two lines have in common. So if you had two lines that were parallel to each other, that went on and on forever, and never crossed, you would have no solution in this case. And then the other thing that we have infinitely many solutions is if you actually work the two equations out and graph them, and they actually end up lying on top of each other. So you graph one, let me do the second one in a different color, and you graph the second one, and they are actually the exact same line. So we say infinitely many in this case because every point is an intersection point.